Hello, my name is Sanford Selznick, and I am a partner in Ascending Node Technologies. In Spaceline today, we're going to be discussing Geometries management and how it pertains to NAIF Spice kernels. We will not be discussing TLEs, and we will not be discussing geometries from other sources within Spaceline. Those will be reserved for other videos. So, geometries, why? Geometries tell us where the spacecraft is in time. It tells us where the spacecraft was pointing in time. And since everything's relative to time, it tells us how much that time has slipped or drifted in our clocks. It helps us avoid leap seconds and things like that. It also can tell us where our instruments should be pointing in the future or in the past. As an example here in Spaceline, we can see that we have instrument fields of view looking at our asteroid target. At this very specific time, according to these kernels that are currently loaded, this is what an image would see had we snapped the shutter at that exact moment. Since we also have data from planets and where they are geometrically, we can compute the light time between the Earth and Mars, which is something that everybody always seems to want to do once because it's fun. So since we're talking about kernels here, you may have noticed the kernels tab at the top of Spaceline here. And so if we click it, we see a list of kernels that have been copied into Spaceline. These kernels include everything from the trajectory files through the attitude files, through leap seconds, and much more. Because there are so many kernels that can be presented to a mission over the course from launch to completion, we have a full search functionality where you can search for kernels of types and by date ranges and so forth. And that's all contained there. Once you have kernels, you can take them all to create a metakernel. Now, we don't have traditional metakernels in Spaceline because we are in the cloud in a server, and so we have something called virtual metakernels. And these virtual metakernels are identical to metakernels, but they are all stored in a database. To build a metakernel or virtual metakernel, you would basically click on a kernel's little white arrow here, and they would get added to the virtual metakernel builder that we have on the right. Because these kernels are time-based and order is important for priority, these kernels can be dragged around and reordered within the easy-to-use user interface. When you're satisfied with the kernels that you have loaded into Spaceline, into this metakernel builder, you just push the Save button, and it gets an ID and it's latched. And then you can email that kernel to your entire team, and they can use it for whatever they need. And you're all using the same source, which is oh so important. If your team gets out of sync on any of these data that are flowing into Spaceline and important to your mission, you're going to have a bad time. And people are going to have to waste a lot of time figuring out why what one person calculated doesn't match up with what someone else calculated. So we have these capabilities for metakernels, and of course then we also have an entire area for metakernels themselves. Kernels, of course, have a corn icon, and groups of kernels have a popcorn box. Get it? Multiple pieces of corn into a popcorn box. So we do an exhaustive analysis of all kernels when they come into Spaceline, and that includes all of their coverage. We have picked a few kernels from a previous mission that are all in the public domain that had gaps in them. Kernels of attitude data can often have gaps because these data are collected off the spacecraft. Things go wrong on spacecraft. Instruments may not send their data properly for storage. There may be downlink issues. There may be algorithmic issues. There could be resets by no fault of one system or another. And they arrive on the ground and data are missing. And that's tough because if you're trying to compute what your camera saw at a specific point in time and you don't have the attitude data for that time, then you're not going to get a good computation. So what's nice is we can't rescue that, but we can tell you where the problem is. And finding these problems is difficult, but we make it easy in Spaceline. We also have culled all the information from the kernels, like the comments and metadata, names and file info and so forth. These can be downloaded and used, and they can also be used by your own scripts within your mission's cloud. So how do we make all this work? So within Spaceline, we actually have the ability to select kernels from the database and create metakernels for a purpose automatically. And this is best shown through three of our preferences panels built into Spaceline: file treatments, grammars, and purposes. The first thing we have to do is a lexical analysis of the file names. Kernels often do not have data within them or metadata within them that are necessary for a successful mission, so these are encoded in the file name. And we have a full regular expression system where we can scan these file names and pull out data like hours, minutes, and seconds, or day of year, or month of year. And then we can normalize all those times into an internal format within Spaceline for easy and consistent use. Once we have done that analysis of the names, we can then tag kernels based on what we found in the name and what we found within the kernel itself. This is all part of that exhaustive analysis. And so we can then set tags on kernels, and we can set types within the database on them, and more. You can set multiple tags and do all sorts of things with them. Once a kernel has lots of metadata in Spaceline associated with it, then we can define a purpose for a metakernel. And a metakernel is basically an assembly of kernels that match the tags over the timeline that you're interested in. So if we head on back to see this in use to the metakernel area, and we ask Spaceline to suggest a kernel for a purpose, here we have a dolphin icon for purpose. It's the closest we could find to purpose. You could push suggest, you could put in some dates, 2005, I have to type that correctly, hit the squid to get a nice UTC date to 2008, hit the squid to get a nice UTC date, hit your purpose of generic kernels and then generate, and this will go into the database, find all the kernels you need for the purpose that was defined, and you're done. And this is a very repetitive task, and we have done it specifically because it is so arduous. So with the suggest button, you can automate a lot of that. Of course, all of this is available by API, so if you want to kick this off from any scripting language of your choice, it's all very easy to do. So that, in a nutshell, is Spice kernel management and some of its features within Spaceline. If you have any questions, please reach out. We'd love to talk to you about this. Thank you very much for your time.